Hi, I'm Bryson, and really miss hanging out with everybody every year like the years past. Look forward to hoisting a beer together next year in person. This is a really cool project that we did. So Urban and the team brought us in to run multiple realistic APTs in their environment to see what would happen. And so me and George here are going to run through all the details of how we took NMFTA from zero to hero with as much detail as possible to see what actually happened.
Hi, everyone. I'm George Archies, and I'm the Chief Technology Officer at SCYTHE, working with Bryson. I'm also a SANS instructor and really like purple teaming because of the efficiencies. So in the next half hour, we're going to take you through what is a purple team exercise. We have a free framework available, and of course, we have references at the end. But you can download this free framework for doing purple teaming. We start with cyber threat intelligence, understand adversaries that are likely to attack a given organization. We prepare, we do red teaming and blue teaming, and we execute the exercise. We emulate those adversaries and then efficiently create detections and alerting for it. And then, like anything else, we have lessons learned. So we're going to take you through this journey.
So in short, what did we do? It says 6 weeks. That's what the actual exercise is. But with planning, it was about a 2-month project in what's called an assumed breach scenario. Assumed breach is exactly what it sounds like. We've assumed the attackers have already gained access. I think the world is pretty simple when we look at attack phases. There's multiple models, but the way I look at it, you have recon, you have access, and you have post-access. Recon, I'm casing and understanding everything I can to gain the intelligence around your organization. Access, which can be technical or non-technical, I'm getting into that organization. And then post-access is fundamentally where you make the donuts. That's where I'm going to be executing TTPs to accomplish my goals over a period of time, which is the entire reason that I got this access. So a purple team, because I know a lot of folks are like, great, we got another color to remember. What's next? Polka dots? A purple team is just an evolution of the risk assessments that you've always seen in the past, shedding the inefficiencies of those approaches, focused on let's bring a whole team together where we can work milestone by milestone through real adversarial TTPs. And so we have the CTI team, red and blue teams, obviously, forensics and response, managed security, all pulled together. In this project, SCYTHE did all of that for NMFTA with the goal of spending no more money on new technology. Turns out a lot of those high-paid items that you got, it's not that they don't work or that you need something else. We just got to tune them in to making sure that they work for you. So how did we do it? Well, over those 6 weeks, we started with the baseline. All right, where are we? Because one of the things about security is it's not that you necessarily achieve perfect security, hit the bingo card in the checklist of, okay, I've done these things and now I'm always secure. It's understanding where am I relative to the threats that I understand that are important to me. And so that's what we did. We baselined, and then we started working through different levels of sophistication from the Chinese, the Russians, and the Iranians, all the way up to the final week, which was a free play focused on what the operators felt like made the most sense. So I was talking about the 3 phases. The value of post-access, and this is specifically why Urban wanted it, Urban felt comfortable that he understood his perimeter. It's not that the perimeter isn't still important. We know it is permeable, though. We know that attackers are going to get access. A determined attacker will get in. The value is, of course, that the contextual business risk, like I said, where I was joking about making the donuts, that comes in the post-access environment. What happens to me, my company, my business, my organization, we see that once they're in the environment. So the metaphor I like to use here is it's like a burglar. Recon, the burglar is going to be casing the neighborhood and seeing which houses look interesting, who's got the valuables, and how do I get them. Access, jiggle some doors, pick some locks, go through a window. Once they've picked that lock, they have access. Now, here's the thing, right? You might not like that they have access to your house, but they haven't actually stolen anything yet. They haven't crossed that threshold. That's why we tie the higher level of business value to the fact that once they do come into the house, how are they going around and taking the jewelry? How are they manipulating things? How are they taking stuff? George, baseline.
Yep. So from an executive summary perspective, just so you see what we're going to discuss a little further, is we tested 65 TTPs. These are tactics, techniques, and procedures, or adversary behaviors, and 94% of them were not detected in the assumed breach scenario. So we weren't doing initial access. We're focusing on that post-exploitation. There were 3 test cases that were caught. Those were related to scheduled tasks being created, a method of persistence. And 1 test case was blocked. So if prior to this, a adversary that we were emulating would have targeted an MFTA, they would have been successful. After all our work, week over week, and $0 in technology spending, we achieved a 64% detection rate. We've added a couple test cases, so not that far off from the baseline, 4 new test cases, but in total, 64 detected. And the way we did that was by enabling telemetry on endpoints using Sysmon from Windows, from Microsoft, as well as creating logic for events using the SIM that was used here, which is known as EventSentry. You see their logo there, and we're going to talk quite a bit because all the logic and the tuning was really done on this particular tool that was already in use, just had to be tuned. And the end state was that an adversary trying to get in after our engagement would have been detected in multiple behaviors, which would have alerted and caused a response to that attack. So just going through this fairly quickly, the goals and objectives were to identify adversaries that had the opportunity, intent, and capability to attack, then consume cyber threat intelligence for those adversaries, create adversary emulation plans, emulate those against the target environment, and then tune and create logic and alerts on the on EventSentry. And all of this, again, with $0 increase in tools, $0 increase in tools. So cyber threat intelligence at a very high level is understanding the target organization, identifying the adversary, then gathering that intelligence. And what we want to focus on is on the adversary behaviors, on the tactics, techniques, and procedures. Once we extract those out of various industry reports that don't map to MITRE ATT&CK, we then analyze and organize that, created a plan, and emulated the adversary. So from a high level, the flow that we went through each week was presenting the adversary for that week, understanding their behaviors, understanding the technical details, having a tabletop discussion with the team, seeing what we think would get detected and what would not. Then we would emulate the adversary, most of the time reaching the objective as was shown in the executive summary, and then blue teaming it, going through each TTP, creating and making sure that it was detected, then being sent to a log aggregator or a SIM, and then have some logic that would turn this on. We would then validate it by repeating the same TTP, and at the end, the entire exercise. So as we went through this, being able to repeat the adversary behaviors over and over consistently and reliably in the production environment was extremely important for us to achieve our goals. So what are TTPs we keep mentioning? Those are adversary behaviors. Here we have David Bianco's pyramid of pain. And this is, David Bianco is an incident responder, many years of experience doing this. And what the pyramid says is from the bottom, working your way up to the top, it gets significantly harder to identify an adversary. If we have a hash value of a malicious payload, this is what your antivirus does, right? It gets updated automatically. It's a known bad file, it'll block it. If we know IP addresses or domain names, these are often known as indicators of compromise. If those are provided, we can block those in a firewall pretty easy. But as we get to the top of the pyramid, talking about network and host artifacts, the tools being used by various adversaries, and at the top of the pyramid, that behavior, it becomes a lot harder to identify. because as you'll see when we go through this, a lot of what we do is built-in tools that are built into Windows, that are built into operating systems that aren't malicious on their own. But when we chain them together and execute them in the same manner that the adversary does, then they should at least cause an alert, which would trigger a response and hopefully stopping the attacker at the right level. So why is detection hard? Well, today's environments have gotten extremely complex and very messy, if we can say. After many years of rapid change, and especially now with COVID, right? I think everyone saw a digital transformation occurring way quicker than was planned. These environments get complex. We continue to upgrade them. We continue to migrate to new systems, and we forget some of the other stuff that's running. So once we enable detection, we need people, and people don't scale. And that detection needs data, and that data comes from many sources, right? In this case, we'll talk about firewalls, we'll talk about logs and sysmon and event logs, etc. But you need context. And then you need to triage all of that. You need to create these rules and logic. And this is the place where every organization is different. This is why you have to test yourself. So you tune and turn on your security tools to catch the known bad and allows the known good. So attackers don't want to be detected, which makes it a lot harder. And detection is about intent, not only the activity. So shout out to Anton on security. This is from a blog post that they had. And of course, references on any slide where we reference anyone else's work. So very quickly, SCYTHE played cyber threat intel, red team operator, and blue team. I was the exercise coordinator, and we worked with various folks like Urban and Chad from NMFTA. As they were the sponsors, they hired us. They also helped do the preparation. They were there watching, learning about all of this, and did a lot of remediation. For the attack infrastructure, we use SCYTHE. This is our enterprise-grade platform for performing adversary emulation. Each campaign we create creates a new custom and controlled synthetic malware that gets executed. So it's not going to be caught by your antivirus because we're creating it right there just for this environment. And the whole point of this is that we can execute the same adversary behaviors consistently over and over and over again so that we can measure security controls and then train the people and then measure and improve the processes. So from the target systems, we do like doing all of this in production because in production is where you have all your controls. So we received a number of endpoints and servers, some with standard user access, one with local admin, so we can enable things like sysmon, and a server, of course. We also received production accounts that had access to email, access to internet, and because we were playing the blue team as well, we had access to all the security controls that you have in a normal operation, right? Your endpoint security, your firewalls, your SIEMs, again, using EventSentry, and that's going to play a big role here, as well as email security, although we weren't testing too much email controls. So our baseline, our first week was just understanding the environment. The red team created a synthetic malware that was executed on one of these target systems. It established a command and control heartbeat out over to HTTPS, and we just ran who am I on the command line. Then from the blue team side, we want to ensure we had access to all the tools, access to the controls, see what kind of local logging was happening, see what remote logging was occurring. So here you can see a more visual representation, 5 TTPs, 5 behaviors being ran from defensive agent to setting up command and control, and a little bit of discovery with who am I. None of these were caught. So we use this tool, which is called Vector. SCYTHE integrates into Vector, which is fantastic. We just import it, and you get this view, which is really nice for doing visual representations and tracking progress over time. Nothing was detected, 0% detection. None of these were known. If an adversary tried these, they would not have been detected. So this is where we began implementing controls. We started with implementing sysmon, system monitor. It's from sysinternals. It's completely free, and it's a device driver that is resident on each Windows system and can track things like a process being created, network connections, file creations, etc. And we enabled the first event ID, which is sysmon event ID 1, means a process was created. And it alerts that. It creates a log on the local system. When run DLL32 was executed, command.exe, whoami.exe, and we also enabled that sysmon log to be sent to EventSentry. EventSentry already had this capability, so this made it a lot easier. And then we just had to create the rules and the alerts on EventSentry. So here's an example of a sysmon, this event ID 1, when we ran whoami. With EventSentry, we were able to turn on a lot of this. It already had sysmon integration. It has Active Directory integration and NetFlow data. The NetFlow data was not enabled. That module was not used in this org yet. So you'll see some of the things that pertain to network connectivity outbound not being detected. But overall, we built out these alerts, and this is an example of an alert. Turned it on as an email alert when this particular TTP was executed. So by the end of week 1, we had turned on 4 detections out of the 5 that we did. We were now up at an 80% detection rate just on week 1 with these 5 TTPs. On week 2, we did APT-19. This is a low sophistication Chinese threat actor that's been operating for many years. You can see here, this was our adversary plan. Command and control. Most of the command and control you're going to see is over HTTPS. There's a couple instances where we did a few others. User execution. There was PowerShell being executed here, which was really the net new focus, and a number of discovery and collections. So in a visual representation, command and control over HTTPS, and a lot of discovery. Discovery is the first thing most adversaries are going to do when they land on your system. So you can see here we did various discovery through whoami, ipconfig, net commands, arp commands, wmic, etc. Going back to the baseline, 0% detection. There are 11 new test cases here. None of them were detected. So again, going back to sysmon, we had it on our system that we were testing, and we enabled alerts for things like ipconfig, netstat, netshares, netviews. We also enabled sysmon event ID 3 for network connections and event ID 11 for file creation. We also had powershell.exe detection to come up with. And the first question we always ask is, do you use PowerShell in your environment? Because PowerShell comes as on all supported versions of Windows. So it's there. You can't remove it. It's impossible to remove. We've talked to Microsoft about this. So you have to detect it. And like we hear quite a bit, we heard, we do not use PowerShell here. Great. Let's turn on detection then. We turned on system event ID 1 with PowerShell.exe being executed and turn on the alerts. We got over 100 alerts per day, meaning that the NMFTA does use PowerShell. So we had to tune it. We identified what processes were legitimate, and we said, log these, but don't alert. But then if PowerShell.exe runs that does not match this, then alert that. And we had to retest this multiple times. So this is a SCYTHE instance, the SCYTHE automation. So every time you double click this binary, it was going to run PowerShell.exe, who am I, and run PowerShell.exe with execution bypass and base 64 encoding, and then shut itself down. This was for testing. We ran this 8 times. Between the time we first started turning on the local event, the local logging, to the time that it went through to EventSentry, we tuned the logic around it, and we finally got it tuned to only tell us when malicious PowerShell was executing and not the known PowerShell used by certain solutions in the environment. It was 8 times that we had to repeat this. This is why we have to do this over and over, consistently and reliably, and not really have hands-on keyboard. We create the binary one time, we create the campaign one time with SCYTHE. You can execute as many times as you want. Every time it does exactly the same thing, allowed us to focus on the blue team side, on detecting and tuning. So at the end of week 2, we were up to 73% detection. You rarely will get to 100, so just to level set that, there are areas where it will become much harder to detect, but 73% is excellent. That means we would have caught this adversary if they were attacking. Week 3 was a Russian threat group known as Buhtrap. They do tunneling through DNS and RDP. So this is very common nowadays with the COVID, a lot of RDP being enabled. And whether it's internally or externally, hopefully only internally, it's a lot of traffic that you're going to start seeing. So how do you know which one's good and which one's bad? Well, we created this plan. We also started getting into persistence. So you get onto a target system, you do discovery. Now you want to persist in that environment. Persistence by Buhtrap was through scheduled tasks. So here's a visual representation of that. You see a little less discovery, more collection for this item. So command and control channels. This is the net new this week. Well, we tested DNS, domain name service, right? You have to figure out what the IP is for google.com. So generally this is enabled, and RDP has been enabled quite a bit so that people can work remotely. We also used a module that was created for SCYTHE called Let Me Out of Your Net. This was ported over from Ubix's tool, which tests egress ports. What is allowed outbound? Well, in this case, we actually found that DNS was blocked. They have split DNS, which is the correct way of creating DNS infrastructure. You don't allow DNS straight out onto the network, onto the internet, which was great to see. So in this case, 91% was undetected, with 9% being detected. That one test case, which is great. We highlight and applaud these. So in this case, we also found remote desktop protocol was allowed outbound. Because we were doing this as a purple team, we were able to remediate, or the NMFTA team was able to remediate this in minutes. They knew that this was a wrong configuration. They were able to fix it, and we retested it the same day. We also enabled some other logging for command and control with system event ID 3, and started looking at Windows API calls when people take screenshots, or key logging and clipboarding. This gets very difficult to detect because you can do all this, right? You can do copy and paste, and you can take print screens. So at the end, we had 60% detection for Bloodhound. Week 4, we went to APT33. This is an Iranian threat actor, became a big deal after the assassination of Soleimani. So we, again, took the adversary emulation plan and tested it. You can see here a lot more TTPs. Some of these adversaries repeat TTPs, right? A lot of people are going to do the same discovery. They're going to do the same command and control. And of course, we want to focus on the net new. This case, 88% not detected from the baseline. There was detection for scheduled tasks, which is fantastic. Scheduled tasks are a method of doing persistence. So in this case, we had to go back and tune system event ID 1 a little bit more and enable event ID 11 for file creation. This is files being dropped to disk, a requirement for persistence, and registry modifications. This one is tough because you are calling the registry at all times. You're querying it, you're adding to it, you're removing things from it. So it gets very, very noisy. However, registry modifications allow you to do persistence as well. So we had to look into these and run the TTPs over and over and over to only alert when a registry modification related to persistence was being done. If not, we were going to be getting thousands and thousands of alerts per hour. So we did that. And at the end, we had a 58% detection rate for APT33. Week 5, APT3, this a Chinese threat actor, very well known in the industry, did a lot of work around exfiltration and collection. So you can see here some exfiltration work, some execution that we've already done, but really a focus on exfiltration. 100% not detected, right? So again, this is going back to our original baseline. So we had to look at some new things here as well. Windows API calls, event ID 8 for creating remote threads like run DLL32, file creation, and then more network connections and really mapping those known bads and blocking and alerting on known bads. So at the end of week 5, we were up to 71% detection with only 29% not being detected. And then we came up to week 6. week 6 was the final week, and we had reserved this for free play because we knew in those 5 weeks of hands-on keyboard exercises, we were going to identify areas we wanted to explore, but were not in scope of those APTs. So we had plans to focus on the Windows Domain Controller critical vulnerability that was released by Microsoft, known as Zero Login. Microsoft Exchange also had a vulnerability, doing domain discovery, and doing lateral movement. So one of the things we used was Bloodhound. It's a free tool. It's really 2 tools. SharpHound, which sends a large number of LDAP queries to the domain controller to discover users, machines, groups, and access control lists, or DACLs, as Microsoft calls them. And it connects to every single system on the network to identify who's logged into it. This was not detected, which is very common because all it takes to do this is be a regular system user, a regular Active Directory user. So no detection there. The other thing we found, and this is an image from Bloodhound, was that there was a couple of users as part of the enterprise admin group. This is not good if they're not supposed to be there, because enterprise admin is one of the most privileged groups in Active Directory. This was another example of resolving identified issues in minutes. We then looked at the vulnerabilities that had come out at that time and were being publicly exploited, in particular 2 critical ones from Microsoft, the remote code execution on Exchange and Zero Logon, which resets domain controller credentials. These were being exploited, and neither of these were vulnerable in this environment. Through the 6-week period, we were always checking to see their patch management policy and process, and indeed it was being followed. So this was a great win as well. We attempted lateral movement, and there was a significant investment in lateral movement prevention, and we confirmed that. It was very difficult to move laterally. We tried other tools. We tried PSXSec, PowerShell remoting. We even used Empire as well as SCYTHE, and we're not able to do that. We were able to do Kerberoasting. Kerberoasting is a method of how the domain authenticates, just how Kerberos works. You can pull a service ticket that has the service account's password in there, and then you can crack it. We did find one account, which ironically pertained to a security solution. So that was identified and remediated. We also did things like port scanning, your typical Nmaps. These were alerted. It was kind of funny because Urban knew what we were doing, yet he would still text me and say, "What are you doing?" and send me the alerts that were being triggered and generated. So this was nice to see as well. Then we did some exfiltration. This was an area that needs improvement. We were able to exfiltrate 2 gigs of traffic without any alerts. EventSentry does have a module for this, so that was one of the recommendations, was to enable the NetFlow modules. So at the end state, we had 64% detection, 1 new blocked protocol of RDP, and still 35% not detected, which is significantly better than we started, especially because we didn't buy any new technology. We just tuned the technology that was already there. Another visual representation, always going back to baseline. So this is week over week. We started at 0%, then we improved, then went back to the baseline, improved, back to the baseline, improved. And at the end, there you see the 71% test case being detected or blocked, which is fantastic. So our lasting recommendations here for an MFTA is to continue testing. These adversaries are evolving all the time, so keep testing. Make sure that the controls and all the tuning and all the work we did doesn't get changed or go to waste. Enable some NetFlow on EventSentry and increase the level of sophistication. We have the largest public library of adversary emulation plans. That's what you see here on the right. These are us going through that whole cyber threat intel where we pull the information from cyber threat intel reports and we create adversary emulation plans and share them. And all of this is about sharing to a community. So here are a number of references of what we use. The Purple Team Exercise Framework is free. Adversary emulation plans are free. Sysmon configurations, and shout out to all of Hartong on his configuration of Sysmon modular was free. And then we enabled all these new alerts and logic, which have been provided to EventSentry, and they will be given back to the community.